Hello and welcome to Minds versus Physics. Before I start the video, please subscribe and share so that it should benefit all other students also. Right now we are dealing with electrostatics, in which Coulomb's inverse square law and electric field part, and we are discussing about the most important problems. Concept videos are already done, and these most important, these are must do problems. If you have not done, that means your preparation is not ready for the examinations, right? You are not ready for exam. So, and each problem covers a concept which is combined with electrostatics, and the concepts could be from fluid mechanics, from vectors, from kinematics, from simple harmonic motion. So combination of problems. So these are something like we are combining electrostatics concepts with other physical phenomena, right? Right. Now, three particles each of 1 gram and carrying a charge q are suspended from a common point by insulating massless strings, each 100 centimeter long. So we have three strings, each one of 100 centimeter long. We have three masses of each one 1 gram, and they carry a charge of q, and they are suspended from a common point. So when you say that it is from a common point, it is obvious that when all the three charges are of equal magnitude in charge and mass, they will that means they will repel away from each other, so that they will be in equilibrium at the vertices of equilateral triangle, obviously. But anyhow, that is also given in the problem, right? And they are located at the corners of an equilateral triangle of side 3 centimeter. So what's the side of the equilateral triangle? 3 centimeter. Calculate the charge q. This is the question. Now understand the question. See, three charges are there. So they are separated, right? They are suspended from a point. They will be suspended from a point which exactly lies vertically above the centroid of the equilateral triangle. Yes or no? Right? It exactly lies. Suppose if these three are the charges and now these are the strings. So the point from where the strings are suspended exactly lies vertically above the centroid. Right? Beautiful. Right, now what is that? Q should be determined. To find Q, if we know the force acting, then automatically we will know Q. To find force acting, are the quantities given to us? All the quantities, of course, distance is given to us, right? So no doubt in that. But to find Q, we should have one more equation which can help us in finding Q. So for that, if you observe, there will be a tension always in the string, right? This tension is resolved, right? Suppose if this makes an angle theta, one of the string makes with the vertical, then this also makes an angle theta here. So therefore in this direction you have t cos theta, and in the other direction it is t sin theta. If this is theta, this is also theta, right? So t cos theta, t sin theta, right? So t is resolved into two components in such a way that t cos theta is equal to mg. Weight and t cos theta are balanced, and t sin theta is balanced by the resultant force, right? By the resultant force. Why are we saying it to be resultant force? Because it is a resultant of force because of two charges. See, on this charge there is a force of repulsion in this direction. On this charge, because of this charge, there is a force of repulsion. Both are of equal magnitude, because all the three are of same magnitude, as well as similar charges, as well as at the same distance. So two F's are acting on this, and the resultant, when two vectors are of equal magnitude, then the resultant always bisects the angle between them and is also given by 2f cos theta by 2f cos theta by 2. Since it is an equilateral triangle, you know that at vertex everywhere 60 degrees is there. If this is 60 degrees, this angle is also 60 degrees. So FR acts in this direction opposing t sin theta, where t sin theta is equal to FR. FR is 2f cos theta by 2 cos 60 by 2. So that is cos 30. Now using these two, you have 2 by 1, that means second equation by first equation, you will get tan theta is equal to 2f cos 30 by mg. Mass is given? Yes, mass is given. Why? Because how much did he say? 1 gram. G is known, constant. Cos 30 is a constant. F we don't know. If we know F, obviously we will find Q, right? So now 2, right? So 2 is a constant. So to know the variable in F, what is the variable in F? F already have a distance of separation to be 3, which is given. And 1 by 4 pi epsilon naught is a constant. Now what is the variable here? Q square is a variable. To know the Q square here, we should know tan theta. Once when you know tan theta, our job is done. So now observe the diagram again. So now this is making an, this vertical is making an angle theta with one of the strings. And now if you observe, this is the opposite side of this theta. So if I want tan theta, this opposite side by this height from where the three strings are being suspended. So that height has to be known. So this though everybody knows it. This is from the vertex. It is an equilateral triangle. Therefore this is an altitude here. And the height of the triangle is always root 3a by 2, right, of an equilateral triangle where a is the side. So root 3a by 2 is the total, where from the vertex to the centroid it is 2/3, right, 2/3 of the total height. So therefore you know this side, right, the opposite side of theta we know. Now we have to find out this one, h. We have already hypotenuse is equal to L. So therefore h is equal to square root of L square minus OA square. Right, OA, where OA is 2/3 of AD, where AD is root 3L by root 3A by 2. Fantastic, very easy. So therefore now you will be getting 2/3 of AD, which is equal to 2/3 of root 3 by 2 into A is 3. So 3 will get cancelled and 2 will get cancelled, and we are left with root 3. So we got this side to be root 3. This side to be root 3. Now find out this one. So L square minus h is equal to square root of L square minus root 3 whole square is 3. 100 square, where L is given to be length of the each string is 100 centimeters. Right? So when compared to 100 square, 3 is very, very small. So therefore neglecting this one, we can approximate it to 100. So we got this height also to be equal to 100. We got the height, that is the adjacent side of theta, and we know the opposite side, which is root 3. So what is tan theta? We are done. We know now tan theta, we know cos theta, we know mg. So you find f. Very direct, right? So now from now onwards it's very direct and very simple. Everybody can do that one. So now therefore tan theta is equal to opposite side by, that is root 3 by h is 100, which is equal to 2 into f is 1 by 4 pi epsilon naught, that is 9 into 10 to the power of 9 into q square by d square. What is the distance of separation between two charges? It is the side of the triangle. So 3 square. Right now 3 meters is given everywhere. Is it meters or centimeters? Let us check. 100 centimeter length is given, 3 centimeters only. Here this is everything is given in centimeters. So now we have to convert it into meters. 3 into 10 power minus 2 whole square. Okay, here though it is anyhow ratio, so no need of conversion. Alright, so 2 into 9 into 10 to the power of 9 into q square by d square. So f part is done. Now cos 30. What is cos 30 is equal to root 3 by 2. Right, into 1 by mg. 1 by mg. M is equal to 1 gram given. G is 10 meter per second square. So m is 1 gram. 1 gram in the sense 10 power minus 3 kilogram. Right, into G is 10. So we converted everything into CGS units so that we'll get the charge in coulombs. Okay, right. So therefore now simplifying further, we will get q square is equal to, so root 3 by 100. Even you can do this. So 2 will get cancelled. Right, so 9 into 10 power 9 into q square by again 9 here into 10 power minus 4, right, into 10 power minus 3 into 10 into root 3, right? So 9 will get cancelled. 10 power minus 4 minus 3 is minus 7 plus 1 is minus 6. Minus 6 when it goes here, it will become plus 6. 10 power 9 plus 6 is 10 power 15. So now this is equal to root 3 into 10 power 15 q square. Right. So now q square is equal to root 3 divided by root 3 into 10 power 15 into 100. Root 3 will get cancelled. So 10 power 15 into 10 square is 10 power 17. So it is 10 power minus 17. Right? So anywhere did we miss anything? Because it is so longer substitutions. 4 pi epsilon naught is 9 into 10 to the power of 9. Q square is fine. By d square is 10 into 3 into 10 power minus 2 whole square into cos 30 is root 3 by 2 into 10 power minus 3 into 3. Clear? Anywhere else? So this root 3 will get cancelled. Right. So this is q square is equal to 10 power minus 17 coulomb. Let us check the simplification. So copy this one and please check the simplification if at all we are wrong anywhere, because we got it to be 10 power minus 17. Somewhere we have to see something is missing here. So now let us see the next problem. Anyway, in the just now problem, maybe that is 3 meters of length, not 3 centimeter, or a textbook print mistake would be there in SI unit. Therefore, we got q square is equal to 10 power minus 17. If not, it would have been like q square is equal to 10 power some even number, right? So now coming to this point, so a ring of radius 0.1 meter is made out of a thin metallic wire of area of cross section this much. So what is given? The metallic wire area of cross section is given. The ring has a uniform charge of pi coulombs. So what the ring is having? It is having a charge of pi coulombs. Complete uniform charge distribution. Find the charge change in the radius of the ring when a charge of 10 power minus 8 coulomb is placed at the center of the ring. So now we have a ring, okay? And there is an uniform charge of Q spread everywhere, okay? Right. So now you are keeping a capital Q here. What happens? There will be a repulsion everywhere, is it not? At every point there will be a repulsion because of this positive charge Q, as the ring is also positively charged. So what happens now? There will be an increase. There will be an increase in the radius of the ring. So that change in the radius of the ring he is asking us to find out. Okay, right. So for this one, what we will do, see, whenever it is uniform charge distribution, we always consider a small charge dq, right, in a small length of dl, whereas the small length, if it is starting from 0 to the end, it is 2 pi r, is it not? So the charge can be q by 2 pi r. So this will always be there, right? So you will always consider it to be like this, right? Now coming to the part of how to understand. See, now we are considering this element of charge q. On this there should be a force of F. But how to find out the force? We can't apply Coulomb's inverse square law directly for the whole ring. So we are considering only small element dq. So small element dq is in a small element of dl here. Right. So now here when you talk about this one, so the tension in the ring is T acting in this direction. If this is theta, this is T cos theta and this is T sin theta. Is it not in this direction? T sin theta. So therefore in both the directions if you consider T, you will get T sin theta plus T sin theta, which is 2T sin theta, which is equated to force. So therefore force is equal to 2T sin theta. So this is one relationship what you will be getting. right? So but what is force is equal to? Force is 1 by 4 pi epsilon. Let me write it as 9 into 10 to the power of 9. Right, so 1 that into q, into what is the q? Capital Q, into q2. What is q2 here? You are taking dq, right? dq by r square, or the distance square. The distance here is the radius, so r square. This is the force, right? Which is equal to 2t sine theta. Now coming to sine theta, see, two concepts, two ways you can do it. Like say this is very small, we take it as a straight line, right? So this is dl by 2, opposite side is dl by 2, and the hypotenuse is r. So sine theta is equal to opposite by hypotenuse. So therefore it is dl by 2 into r. This is one concept where you can directly substitute sine theta, or the other way around. Some other people will be telling it as theta. This is the length of the arc, right? Where what is the length of the arc is equal to dl by 2. Very good. So therefore theta is equal to dl by 2 by r. Why? Because like when theta is very 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 small, sine theta is equal to theta. So in both the ways you can solve the problem. So now I am taking it directly 2t into sine theta. So taking it to be a straight line because it's very very small. Or rather you can take it as sine theta is equal to theta for small angles, and theta is equal to arc by radius. Done, finished. So till this problem it is very much clear. Right, now the problem, now let us rearrange the terms and find out t, okay. Let's see, 2 will get cancelled. So now t is equal to, so 1 r and r will also will get cancelled. So t is equal to cross multiplication, dl will come here. 9 into 10 to the power of 9 into q into dq by r. I'll write dl here. Why? Because my dq by dl is equal to q by 2 pi r. Right, where r being the radius, here the r is capital R, so therefore you are taking this one. So thus you will write it as 9 into 10 to the power of 9 into q. dq by dl can be written as small q by 2 pi r. 2 pi r into r is 4 pi, 2 pi r square. 2 pi r into r, 2 pi r square. So this is what t is. So we know the tension now. Right, so tension because of the like whatever the forces which are acting between the small charge q, small q and capital Q. So we got the tension. Now the problem here is, because here now we know that it expands, right, or it elongates rather than it, there is a change in the radius. Right, now let us suppose that the change in the radius is delta r. Right, this change is per unit length, but that means per the initial radius r. So therefore change in the radius divided by r, this is equal to strain. Is it not? Because he had given us Young's modulus. Right, he has given us Young's modulus. So therefore now we got strain is equal to delta r by r is equal to strain. And then stress. What is stress? Is equal to force by area of cross section. What is the force which is acting on this? Is tension only. So tension by area of cross section is equal to stress. So now we got strain and stress. Then now Young's modulus y is equal to stress by strain. Stress by strain. So therefore y is equal to, what is stress? T by A, right? Stress by strain is delta r by r. Right, so this is what now we got it. So now let us do this one. Delta r by r into y is equal to T by A. Is it not? Where A being area of cross section. Area of cross section is already given to be 10 power minus 6 meters square. Right. So now Young's modulus is given. A is given. Okay. Right. Now charge small q is given to us. Right. So now what else? What else is there? Radius is given capital R, which is 0.1 meter. Right. So therefore now we have to find out only delta R. Right, so hence delta r is equal to, so we'll write the whole equation. I'll write the whole equation. Simplification part you can do it. So T r by y a, T r by y a. What is my T? 9 into 10 power 9 into q by 2 pi r square is T into R by Young's modulus of the metal is given to be 2 into 10 to the power of 11, right? Into area of cross section is given to be 10 power minus 6 meters square, right? So now substituting all these values, you will find delta R. Okay, so I'm leaving the simplification part to you. So till here the perfectly all right, and here and there simplification. So answer always, don't trust the books only. You do by yourself. Somewhere here with the decimal point values or some units there will be some change. Okay, this is all for today, and please subscribe, and thank you for watching. Share with your friends.